Good morning, Ariel. I don't know why I put you down as Intel. I think I was just messaging someone from Intel and
Yeah.
yes, uncle.
Hey, good morning, good afternoon.
Actually, Zonka, I wanted to ask someone from NVIDIA this question, and forgive me if it's naive. Um, so the normal model of confidential computing is there is some code and perhaps a little bit of data, maybe configuration data, your roots of trust, and maybe like, the public key you hold, whatever. And then you go and attest, and then you get some sort of credential because you're running this code and this configuration. But when it comes to uh, machine learning, there is little code, but there is an enormous amount of data involved. And when we start looking at agentic AI and giving credentials to agents, the important part of the attestation process actually involves the data. And what is unclear to me, like we're hearing about these models with billions or trillions of parameters. I don't even know how high these things get right now. I would imagine these models don't fit in memory all at once. So it would be really nice for someone who understands this space to explain to the rest of us how to create identities around machine learning models and agents, right? And because it's effectively the data to code relationship is flipped on its head.
Right, there's some work going on upstream on model fingerprinting. I don't know if this is particular answering your questions on if the complete model fits into memory or not. I can follow up on that and see
Yeah,
where we are at
right.
with that. But
With
yeah, you're
code,
right.
we have essentially code signing, and like
Yeah,
it's rare that the amount of code you run is more than 10 megabytes per whatever.
yeah,
We don't attest huge swaths of code, and then models change. You get RAGs, you get periodic updates to the model, and like as I said, agentic AI is going to be one of the poster children for workload identity going forward because it's just such an important and growing area. We need to start giving these agents identities. There's an entire push in the Cloud Security Alliance to normalize human and non-human identities, which I mean, of course, is going to involve more than that, but agentic is going, right? So I would like that to be one of the outputs of this working group is an explanation of agentic AI and workload
hmm,
identity. So
right.
if you are like NVIDIA is such a natural organization to ask that question.
Yeah. And your
Yeah,
input will
I
be
can.
very useful actually, Zonko.
Yeah, I will follow up on that. It's not only like one or two GPUs, then we are getting into multi-node, and then how do you span a confidential mesh over your
Correct.
pipeline? If you're using RAG, you're not changing the model, but if you're using fine-tuning or training on stuff like that, so you're changing the model. So those are all valid questions. We have a whole team working on that. I can follow up on that and see what information we can share.
Yeah.
Is there okay, for agentic AI, it's one particular use case for workload, right? like different types of workload we have, like lambdas we discussed services, right? So agentic AI is a one specific use case in my view, Mark. Do you
Well,
kind of?
it's one. I mean, there's way more than that, right? But
Mhm.
Other
I
use case would be federated learning, right? When
Yes,
attestation entities are coming in and out, you want to create your trusted cluster. You want to know which nodes are able to get into your federated learning cluster and stuff like that. Yeah, there. Another topic would be like federated learning, which is also a big one.
I absolutely agree. I think we missed that federated learning aspect. Maybe Mark, we should note those two things, agentic AI and federated learning, as
I
two
just did
topics.
in the topics. So and I put Zvonko as
Okay.
a follow-up.
Okay.
Yeah.
Okay.
If I may
Cool.
jump in. Hello, everyone. Sorry I could
Hi.
not attend last week. I was busy with the RSA thing
Yeah.
and Europe stuff. Actually, just to chime in, the way that we handle data or information security at the process level is really by having the identity of the workload, which we call an agent in our system, although they're not AI agents, but it's basically having a secret key per agent. And that secret key then enables the derivation of other encryption keys, which enables the agent to encrypt its own information space.
Mhm.
And by the way, Zvonko, that's something that we'd love to talk to NVIDIA about because we do think that is it's the optimal approach that each workload or agent would have its own primary key from which it can derive other keys for different contexts and then encrypt its own information when it crosses, when it moves outside of the of the isolation boundary of the TE. So that unifies encryption. The TE provides the isolation within the boundary. But then the agent can have its own keychain so that it can encrypt its own information when, at rest, when it moves outside, but also in transit. So in that, Mark, goes back to the problem that we are tackling for all types of workloads, which is the establishment of a secure connection between two workloads.
Yeah.
That's what I call the in-transit at the workload level or at the
Right.
process level. And so that's how we tackle this.
Okay. So let me speak to that. So I was actually talking to Vikas. He's the head of product and confidential at Microsoft, and he was not up to speed on workload identity business, and he asked me to justify what we're doing to him. And the way I explained it to him, and anyone who cares ask, I suppose, is that when we have a large volume of applications, so at the bank we have some mid four-figure, I don't know, 6,500. I don't even know the number, but it's in that ballpark number of applications. The way they operate, and if we're going to uplift them, we can't really break that thing, is different from the way normal confidential computing workload is deployed today. Today, for confidential computing, you attest, you use the result of attestation to procure a key. And then you're assuming that the data is stored somewhere encrypted already with that key. And then you go fetch the data encrypted, you decrypt it inside your isolation boundary, and you party on. And that's simply not how the rest of the world operates.
So Mark, you're
Consumer,
frozen.
right?
Can you roll back 5 seconds? You were frozen for 5 seconds.
Yeah, sorry. So the way a normal application today works is it goes, gets some sort of a credential, and then it goes authenticates to some data store, and then over the transport level, it downloads data that's already decrypted. There is no key procurement that happens, right? So when you talk to when we talk about agents and generally machine learning, the data, the model is the code, and the size of the model is vastly in excess of the amount of code that you have. So you have, there's probably orders of magnitude difference between the size of the Python script that operates on the model and the model itself. So it's I mean, of course, we could say that, okay, here is a model, it's encrypted using a key, and here is the code, right, that goes and fetches that model and decrypts it. I don't know if I, because then the identity of the agent is really, most of it is in the model. And if the model were to change, the same relatively tiny amount of code that serves results using that model is going to give you vastly different results. It's effectively doing vastly different actions. So what you described sounds to me like the model where you have to procure a secret in order to get the data. And I'm saying the data we can assume is in plain text. And the data forms the foundation.
I'm sorry, you're saying the data assumes what?
I'm basically assuming that for effectively the data that constitutes the identity of the agent, because it drives its behavior to a huge extent, is the model, and it's effectively in plain text. So you need to attest it, not the code that accesses it. Again, I may be completely off base and wrong about this, but that's my strong intuition, and this is why I'm asking Zvonko to get back to us and sort of explain what the suggested mechanisms are, so we can discuss them here.
Yeah, that would be great.
So,
that would be great. I second that.
Okay, so let's see. So the
just a comment before we start moving.
Mhm.
I mean, I was presenting in the interim ITF last week about roles, multiple types of verifier, and there I presented a use case, which is Intel Trust Authority in working with NVIDIA Remote Attestation Service, those two independent trust verifiers, where the trustworthiness of those two entities are used to deploy confidential model as well as confidential data into a trusted execution environment. So I think data encryption is also equally important as well
Yes.
as the model encryption. The code encryption is important, but at the same time, the data owner wants to encrypt the data as well, which operates on these models. So
Well, encrypt at rest, or because, like, again, we have data encryption at rest that serves certain purposes, like basically if you lose your laptop, you don't lose all your data. But
I think it is the data that is used in use, I think. But maybe Zonko, if you have this stuff which I'm just sharing, if you have seen this, maybe you can shed more light. This is a public information I have pulled on that.
We can't see it.
So,
Okay. Oh, there you go.
so the the encrypted DB is the data owner where you have data decryption happening in the TEE once the attestation of the uh, trustworthiness of the workload uh, and the platform is done. So
yes, would you mind putting this link into the chat so we can include it in the meeting minutes? And
yeah,
there is,
sure.
and if you stop
Yeah,
sharing for a second, I want to show something as well.
yeah.
So let me see. Or maybe you can share. I'll just put the link. So
No, that's fine. Yeah,
well, it's just
please.
my screen is huge, and if I share, you won't be able to see it. So there is here's a link that I would like you guys to take a look at. So I was in a meeting with Spiffy last week because I'm
Okay.
talking to them about incorporating a confidential computing into their workload. So for those who don't follow Spiffy, Spiffy has this thing called the Workload API, and they have this concept of a node attester. And it goes very well with the Whimsy model where you trust the node attests, and then the workload asks the node to get its credentials. And there is the Spiral server that the node attester talks to, but the workload doesn't really talk to the Spiral server directly. And if you look at the Workload API, there is no possibility of incorporating attestation into that. It's just like it's at the API level. There is no way to supply information. Effectively, the Spiffy model requires the node attester to introspect the workload and to grant an identity based on that, which works in large number of scenarios. It does not work with attestation. So I brought this up to them, and it turns out that they're working on this whole Istio mesh where they have a similar problem, and there's called the ambient mode. That again, follow up on that. And if you were to open up this link and share the screen, I guess you'll see that they are proposing something that, at least superficially, can work. So they're working out this broker or proxy that does it, and this is in a sidecar type of environment. And the idea is there is a way now for the workload to get credentials through this broker, which does the attestation on the workload's behalf. Which again, if it's a sidecar and in the same pod, and the broker tests the entire pod, okay.
So if the broker does the
work.
attestation of what?
Well, they're doing the attestation of I guess the workload slash broker combination. And this is again, this is the broker is the sidecar. So it runs in the same trust execution environment as the workload, right? So the pod normally is the trust boundary. So if there is a number of workloads, they all can get identities through this broker. And again, what would be nice for us to do is to analyze this proposal and to see if it's suitable for confidential computing. And if it's not, then we can raise it with them. They do have an interest. So SPIFFE does want to support confidential computing. The question is figuring out how. And if this does not work, then we should say something. All right, that's, again, I am not ready to voice my opinion on this just yet. I haven't finished analyzing it.
But Mark, can we dwell on this for a little bit longer?
Yeah, absolutely.
Can you say again, the workload and the broker are running within the same TE?
Trust boundary, yeah.
The same trust boundary. So the broker is just a library or some sort of SDK that you
A
slap in.
sidecar. It's basically, this is, if you read the full context of this issue, it's for sidecar, yeah. So and it's done for Istio mesh, right? So the idea is they want workload to workload authentication, and they want to be able to procure credentials for individual workloads so they can go talk to each other in this mesh. And they're proposing to do this. And this, again, the context of this is not confidential computing, it is Istio. The question is, will this model also work for confidential computing in combination with SPIFFE?
Okay.
So this is assumed that the SPIFFE workload endpoint goes and take the attestation and then do the trustworthiness decision.
I'm assuming here that when this says attest via
Hmm.
API, that it is attesting all the workloads that run in the same trust execution environment as the broker, because you'll see that they're
Okay.
doing it for each workload.
Okay.
All right. So again, all the workloads are in the same trust boundary. So it's one pod where the broker is doing the credential procurement for each individual workload. And again, if we can make it work, that's good. If we cannot make it work, then it would be nice to respond and say, okay, guys,
Yeah.
nice try, but
Yeah, it needs to understand what their attestation means. Is it the trust boundary only about the workload or the platform on which the workload run? What is their confidentiality with the host? Is host part of their TCB or not part of their TCB? And all those questions needs to be answered before we can make a call.
well, so yes, here's what we could do perhaps by next meeting is collect sort of questions and
Yeah.
analysis of this proposal and again, I can share with anyone who's interested the details of that SPIFFE meeting. It sounds like it's open, much like our meeting here is. And I would like to have that discussion with them because, again, much like I would like to bring Whimsy, become compatible with Whimsy, I'd like to also become compatible with SPIFFE. It seems like a winning technology for a lot of enterprises, as is Istio. So we need to play in that space.
Yeah, just a comment on that. For confidential containers, we built something similar to have a confidential mesh as a encrypted overlay over the Kubernetes API stuff, because essentially what we are doing, we are sharing the control plane with each tenants, and Istio is for the complete cluster, and customers do not like sidecar containers because there's always something injected into their workload that they do not like. So if they're running a pod, a container, they don't want to see any sidecars loaded. And what we've done is to couple the Lighthouse, the CA, which is providing the certificates to join the confidential mesh, is tied to the attestation pipeline. So only if our TCB is attested, the Lighthouse or the KBS, which is the same entity, provides the certificates for a container to join this confidential mesh. So
Do you have this write-up
yeah,
that
I
you
will
can
do this
share
right
with
up. I
us?
wanted to share it with this group as well to showcase how we're doing it in confidential containers, because we are tying then the attestation pipeline of the TCB with the provisioning of the certificates to the tenants of this confidential mesh. And if you're looking at the rec pipeline, if you have your re-ranking service, you have embedding service, and you have your LangChain and whatever else entities, you don't want to share the complete Istio mesh with all those components. You want to have a confidential mesh only on those components working in tandem, right? You don't want to share anything. As soon as you're sharing, you're creating an attack vector. And the same for the confidential control plane. Anyway, so I can share some details how we're doing in confidential containers with this Nebula CNI, which is a overlay on top of the Kubernetes plane, and how we are tying it to the attestation. It does not involve platform attestation, so this is one piece missing. It's more concentrated on the TCB.
Okay. Well, so it's good for us to have sort of a library of existing efforts, so so we can navigate this entire space. I also am putting a link. This showed up on the TAC mailing list, so I'm sure you've seen it, but in case you haven't, so somebody did a write-up and proposal for confidential computing for serverless. So basically for microsecond or millisecond type workloads. It's, if you remember, in an earlier meeting in this group, we discussed this provisioning mode versus acquisition mode. Sorry, acquisition, like provisioning, acquisition, and use of credentials, the three stages, which is a very simple model, which is probably good. This is more involved. This is a, it's more than a proposal. It's like whole architecture, multi-layered, significantly more complex. But also good to review and take a look at to see if anything can be learned from it or used from it.
Yeah, it's a question on multi-tenancy here. I've read it. It depends on your trust model, right? If you want to run multiple functions in a single CVM, or do we want to isolate each function? I didn't get if from this paper, I didn't get if they're proposing to run multi-tenant functions inside of a single CVM, or functions of one single tenant, multiple functions of a single tenant running in the CVM. So this
Might
is
make
not
sense to
here.
reach out to the authors of the paper and ask them.
Yeah.
Maybe you can do that. Shoot them an email,
Yeah, I
see
will
what
do
they
that
say.
because I think this will not fit really nice with the GPU use case. Just of the constraints they are setting up. But anyway, I will follow up with the
Okay.
with
So
the
and the link to the thing you just mentioned would also be nice.
Yeah.
Also to include the meeting minutes so we can sort of week to week review existing development. All right, Yogesh.
Yeah.
We're now ready to.
So I was didn't do much, but I kind of tried to create sections based on what we discussed last week. But I think overall we want to decide what exactly we want to present there. Do we want to present the full architecture, what we are proposing in Tester TWI, or we want to just express the commonalities with Whimsy versus the diversity with Whimsy? What is the kind of motivation for our work in ITF?
We should probably go around the horn and answer a question like from each of our perspectives. I'll start. I think that we should highlight the delta between what we're proposing and Whimsy,
Okay.
and then illustrate with like swim lane diagrams or other mechanisms how we propose that we're going to integrate with Whimsy, and and if there's anything we need from them, like for instance, provenance is something we need. I looked at the changes you've made so far. I would probably word things a little differently, but in principle, We basically want to say, this is how you integrate with with attestation in the credential issuance pipeline, and also please include provenance. And this is what that might mean. So that would be my answer.
Okay. Any other ideas? Welcome. Like,
So unfortunately, I missed last week, and I apologize for that. But the one thing that I think, as the CCC keeps coming back to me, is Whimsy doesn't have the level of attestation that we have, right? The strength of it is very, very strong. Obviously, orders of magnitude stronger than anything you could do without a TE. And so the question really then becomes on the verifier side is, where do the reference values come from? Where do the endorsement values come from? And then when you pass a public key to a relying party, how does the relying party know where that public key is coming from? If there's no a chain of custody between the relying party and the workload that the attestee, right? Then there could be a man in the middle, and all the efforts that we put into getting that public-private key pair, that attestation process can be undermined silently if the relying party is using a public key that has a man in the middle. And so I think from our perspective, it always comes back to, is the verifier verified? What is the chain of custody for all the artifacts that are used in making the decision, and how does the relying party know that all the artifacts have been tamper-proof in making the decision?
So I can make few judgment on that. So first of all, the attestation results which the relying party consumes from a verifier is a signed document. So so that nobody in the man in the middle can change or overwrite or modify that. And the trust is the verifier trust. The relying party trusts the verifier in that. So
yeah, but
that
so
gives
in a fast-moving agent world, each one of these agents will have their own public keys, and then again, yes, you have the trust of you basically assume trusting the verifier, but if the verifier, or if the relying party is in a separate domain, and is how to say that, have not been introduced before, right? How do you automate the exchange of public keys with a level of assurance that matches the assurance that we have at the attestation layer of the TE?
To that, this is what I'd like to add to that. So in establishing any kind of trust, again, in the real world, hash mesh is kind of a perfect next level world. The world exists today. There are verifiers, there are certificate authorities, there are HSMs, there are build chains, there's all sorts of things. So I think our job has to be to enable the building of the necessary level of trust, but leaving the decision as to how far to take it to the deployer, to the implementer. And for instance, if you want to follow the breadcrumbs to, how much can I trust the verifier, is certainly an option that should be left open. On the other hand, the establishment of a trust in verifier may be a binary out-of-band decision. And that is also something that an implementer may choose to do depending on their context. So, right, so for instance, this is where I'm saying, we're not including the entire provenance in every credential. We should probably just have an ability to say there is a provenance identifier, and define a mechanism for how to follow this breadcrumb to other things.
Yeah. Okay. I hear you. But again, I think from the CCC point of view, any weak link in that chain will undermine all the efforts that go. Yeah.
So again, I come from the banking perspective, where it's something I have to swallow grudgingly, but I am in a world where risk is accepted. The important part is to understand the risk, so then you can make a risk acceptance decision. But if somebody is unhappy, with the level of risk, and then your money stops flowing, that's probably not good. And then, you know, maybe we can afford to lose $100 million a day to fraud, but the money is flowing. You know, that's the world.
So, Mark, one request. In this pull request, could you add the link to the TWI core requirements?
I'm
Because
waiting for Rian to create a special TWI repository. And as soon as that is done, because right now, if you go to TWI, it redirects to Whimsy TWI.
Yeah.
And I already,
you asked me to change the name, so it's
yeah,
already
no,
Whimsy
you
TWI.
did. That's all good. I just emailed Rihanna, basically asked her to make sure that there are two separate repositories without a redirect. As soon as that's done, I'm gonna upload the markup version of our requirements to the TWI repository, and then you can reference it from there.
Yeah. So Manu and I think what's the name of the gentleman? I think it was Ariel Feldman, right? So you both have been invited now to the repo. So please check. I think Mark,
did.
you are already. Yeah.
Yeah, I did receive an invite from
Yeah.
Yeah, same here.
And I'm not sure whether Zonko, I have your GitHub ID. If you can please Slack me or in the TWI thread. Yeah, okay. I will add you as well. I will ask Rayan to add you as well so that you can also contribute. Yeah. So yeah, over the next week, I will add some meat to the aspect and how a possible. I think I will just see what is the role of attestation in the credential issuance thing, and then a more specific about passport model and background check model would be added by Henk, I suppose, or somebody else can take that. Yeah. So,
Yeah,
and
we
by
have.
all means, yeah. Yes.
Yeah,
Sonko.
background check is also in the part that I described before. So this would be also an example of the background check model with identities for the confidential mesh. So I can provide this. This will be in the example that I'm going to provide anyway. We can link to
Okay.
that as well.
Yeah, we will have to kind of, I think it is good to squash a bit of example if possible in the use case also if you want, and then we can provide a link to your documents if you have public available documents as
Yeah,
part
we
of
can
the
create
draft.
something. Yeah.
Okay, I think that's pretty much it, Mark. Everybody's welcome to contribute, and at least if not contribute, feel free to review it, document as it comes along. Maybe some update will happen next week, and Mark, feel free to edit as well from your side.
Okay. All right. So,
Yeah.
okay, I don't see then, unless you guys want to go do some sort of real-time review on Yogesh's write-up right now, we can wrap this early and then focus instead on doing commenting, reviewing, and authoring of content.
Yeah.
And also please review the links that I provided in the meeting minutes, and Zonko, also please add yours, and then we can revisit restart next week.
Brilliant. Thank you.
All right. Thank you all.
Thanks.
Thanks.
Bye.
Bye-bye.